will record this. I didn't plan to record, but someone reached out on the LinkedIn when I post about this talk. It's like, oh, I could make it. Like, if you can record this, so we're recording. So welcome to my Netflix special. Netflix will recording, and everything good or bad or whatever these days happens somewhere in the social. And one of the ideas that came into my, like how this talk came around, and some of the ideas what would be interesting topic to talk about came from one of the community members, Robert Zeig. He asked the question like generally, like, because he was involved in the Kafka Streams project, and this type of conversation always happens. Like, okay, so what does it mean to query a stream? The Pavel was talking about like ingestion side of things a lot, so I will be covering the side where you already have this data. This data or somewhere in the Kafka, and we're gonna make some assumptions. And for me, also great would be great to understand like how we, like on the level of expertise. We have like Kafka operators who you know, building clusters and operating clusters in the room. Anyone? Good. Probably that's the people using some sort of managing services, so they don't need to rely on some of the operators to provide them Kafka. Any developers who are writing apps, producers, consumers, stream processing, okay, more, great. Any like data people who are maybe ingesting data from Kafka into some data lake or maybe data warehouse, okay, a few people. We're gonna be covering all these aspects, and I really want to kind of give you a comprehensive overview of what does it mean, and there's multiple dimensions, I would say, because it can be analytical query or it can be transactional query, and we talk about all these things. And a friend of mine, a colleague of mine, Tim replied, yeah, this is not something that you can respond in one tweet, but it will be a great presentation. Hate when this happens. Let me see if I can go. Yep. It works from Watch. Or podcast or blog. So actually it started as a podcast. Tim took a liberty to sit down in the studio and talk to himself in a podcast about this. And after that we come up with collaborating some ideas how we can build a talk around this. So now it is a talk. My name is Viktor Gamov. I work as a principal developer advocate at Confluent. What does it mean? I talk to developers, talk to operators, talk to people, everyone that identifies themselves as a data streaming engineer. I think this is for a very long time, we didn't have a good name for that explains what does it mean to work with Kafka, with stream processing, with streams and all this stuff. And I think we come up with this, like data streaming engineering is another aspect. And I think if you can identify yourself as a data streaming engineer, just raise your hand. Like if you do Kafka, if you do Flink, Spark, you do any type of processing with some of the streaming data. Maybe a little bit batch, maybe, but you know, streaming the main aspect here. You can follow me on X. I will post some other contacts how we can get in touch with me. But always, everything needs to be started somewhere, right? And usually when we're talking about the query, at least myself, when I was getting the university course on databases, I assumed database servers, something like big analytical. And it turns out to be big and analytical, but also you can do something with this, slice this monolith, but we're not there yet. So back in the day, we have a database, one place, everything is easy. Someone will write the data into this monolithic database. Someone will read this data, usually using some sort of structured way of accessing this. In the majority of the cases, SQL will be the language that you will be using to query, because it's the structured query language for structured data, that data that stores inside the tables. And with the monolithical and the traditional databases, many engineers, data engineers, people who are dealing with data, they kind of develop this the muscle or habits of what they want to expect from the system and how to get the answer. So this answer can be something transactional, like for this credit card number, give me a list of transactions. Or it can be something analytical. For example, that can tell the story for all the transactions that happens in this banking account, how many of these transactions come into grocery category or entertainment category. So both queries, both answering some questions. In one case, it tells bigger story. That's why how we can identify or distinguish analytical type of query versus, say, transactional. And in order to start moving things around and providing different teams to get access to different data, different approaches come up. ETL approach, you're reading data, you do some transformation, and you load this in the system where people who are using whatever tool, but they're still interested in your data, they will be able to do this. With CDC, it's very similar, but it actually taps into something that will drive this application data changes. So CDC is a change data capture. When something happens in the database, it also will be propagated in the form of event. For a very long time, the developers and the data engineers, they had to rely on some vendors to provide those tools. For example, many of you probably heard about Oracle Golden Gate. That's the famous replication tool, but essentially what it does, it actually does CDC change data capture. Yeah, that's the idea. With the mobile era, all these approaches were destroyed. And because of the sheer amount of data, there needs to be a new solution. It needs to be something that will be solving the problem with data movement. We're not talking about asking questions yet. So we're getting a lot of data. We're still kind of like moving into ingestion. And this is where people and data engineers start thinking about data pipelines. So the way how the Kafka came about, many of you will know this, is that initially it was the idea to have a faster ingestion for Hadoop, meaning that getting some of the changes that happen in a different system, collect them, and push them to do like a batch process, like a little bit faster batch processing. But the rise of the microservices movement also help to establish another kind of pattern where the streaming tools can be used. For example, microservices communication through events, not only to just like move the data, where every time when we're dealing with the data, the package will itself include something that, transaction. But now we start more thinking about the changes that we can propagate, or some of the events that will be signify or signal changes of the state. So we need to receive in another microservice side of things. Now, log is a universally applicable data structure for capturing all these things. It was used internally through CDC. Why it could not be used externally in a more like a macro aspect? So a log, which is anyone needs explanation what's a log? I'll still will give you, but I was wondering if I'm still have a connection with you or we just like going away. A log essentially it's append-only file. You never change anything in the log, you're writing down. So that's the principle of Kafka. It's a big distributed append log. And what this allows to do fast ingestion. But comparing to like traditional databases, it doesn't give you ways how you can retrieve the data. Okay, you ship the data. The only way how you can retrieve the data is sitting there with consumer, reading, and making sense out of it. If you're trying to get the answer, or you're trying to get a bigger story. Transactional versus analytical. Now, let's get back to this question again, because essentially what he was asking here is that we have a Kafka. And we do have some of the framework available. Can we use this framework as doing traditional things that we used to do with traditional databases? Write a SQL to get answer, write the SQL with some aggregations and some of the functions in order to get like bigger story. And this is basically where we go in deeper to solutions. We're going to explore multiple different use cases. This is very opinionated. Your favorite tool might not be on this slide. You can disagree, and I welcome it. We can discuss this. But I hope you will enjoy the amount of information. And also very important, I will tell you right now, and I will tell you at the end. I will not give you definitive answer. I'll give you a set of tools, I'll give you a set of approaches, and I will show you different ways how you can think about this, and the choice would be yours. You need to pick up something that would be useful for your particular use case. Now, streams, as I said, derived from our use cases. What kind of systems we're building? Is it a transactional system where we need to get answer based on certain criteria? So, key lookup, select star where particular field is equal something. Or we're talking about analytical that would be powered the dashboards or reports on things like that. So that's the difference. I already touched this a little bit before I displayed this slide. Quick remark, we have a word from our sponsor. We, at Confluent, we actually trying to give the full-blown platform for people to build their applications. And the Kafka managed service, for those of you who are not operator and want to start building stuff, that's a pretty good deal. Any Quentin Tarantino and Glorious Bastards fans? Will you take this deal? It's a pretty good deal for me. I'll take this deal. So if you sign up, you will have 400 credits to play with Kafka, schema registry, tons of connectors, the Flink SQL, which is another cool tool I will be briefly covering. So everyone get the code? I'm not going to be incentivized if anyone will sign up, but people will tell me that I'm doing a good job if they see this code was used. So that would be appreciated. Now, back to usual suspects. We're going to start with how we can teach old animal new tricks. So in this case, we're going to see how we can use relational database to query our streams. Kafka Streams, which is also, I can tell, de facto standard for certain things to do, because it's just like a part of Kafka framework. Very cool new set of tools that's called Streaming SQL. And they kind of like a weird mix between how the data would be ingested in a stream fashion and how SQL can be used to express different like querying capabilities. Data warehouses, usually in the cloud these days, data lakes, and the systems that can the kind of like a bridge between the old world of batch and stuff, and real-time analytical databases. Yes, you read this right. There are such thing as real-time analytical, because we were usually told like a OLAP system is something that will need to go through the big chunks of data, and it's maybe part of data warehousing. I'm going to touch a little bit about these real-time analytical databases. Now, Kafka Connect. Anyone used, enjoyed, love it, hate it? Love it, hate it, it's there. It's an amazing framework that allows you to not worry about underlying aspects of producing and consuming data. So what it allows you to, usually it's vendors or developers who are wanted to make their product available through the Kafka, they can implement this connector, or some open source enthusiasts can implement this, or or something in between. Kafka Connect is a system that would be running somewhere next to Kafka. It's another process that will be running. It will be constantly reading Kafka topic and doing something with the data. Simple example, we can have a connector. It's actually a built-in connector that is a part of the Apache Kafka. It's called file connector. So essentially what it can is just simply reading the topic constantly and dumping this data into a file. Or it can do something interesting. And this is where this particular thing relevant for the topic of our conversation today. Kafka Connect, there's a connector called Kafka Connect JDBC connector that virtually connects any type of database into your Kafka. It can read the data from database, which is we're not interested in this particular case because it's more on the ingestion side of things. But also it can write data, so that's why we have two types of connector: sync in source. Source, we need to get the data into Kafka. Sync is get data outside of the Kafka. So with the typical approach, we have a Kafka connector. Will be sitting there, and what it will do, listening all the things that happens on the Kafka topic and dump it into your traditional database. And this is where you can brush up your old skills because you already know this database, you already know this tool. It's just someone will do this like insert of new data, but you will be able to execute the queries. So I'll show you example, quick example, how this would look like. You need to have, in this case, you need to have a separate, in this particular case, I'm using Docker, but in the real world, you need to have Kafka. You need to have a Kafka connector that will be connecting to Kafka, and you can have a bunch of interesting things. For example, there's full flexibility of what kind of data you can ingest. Different types of popular data types are supported. Schema also supported here by connecting this to schema registry. So, for example, Kafka Connect can infer schema of the table where it needs to populate the data. Or based on the data that arrives in Kafka topic, it can do schema evolution and change the schema on underlying system. It's quite powerful. However, it still will not gives us kind of like maybe some of the, depends on requirements. If it's requirements would be, you need to get the query answered of what happened at the stream in the milliseconds, probably would be not ideal solution because your queries needs to be a query would look something like this. In this particular case, I do have simple data, a JDBC connector that reads the data from Kafka topic and saves it into a SQLite file. And in this case, I will be able to read this data, read this information from SQL. But again, every time the data will update it, I need to run this select star or whatever one more time. So you have a latency, you have a data freshness problem here a little bit. So, but it's there. It's something that you can use today without learning new skills, but would it be fun? Of course not. So that's why we're going for the next one. When I say it's suitable for small data, actually it's suitable for big data-ish. Couple, gigabyte, hundreds of gigabytes probably would be still considered small data. I would not suggest to use it with the terabytes, simply because depend on the system that you will be querying, like how fast this system will be answering these queries and stuff like that. Transactional, naturally, we have insert statements that will be written, can be written in batches, but still, essentially, it's a transactional approach for data. You know your database, you know your SQL. Why don't just plug it in the Kafka and just use it? Now, Kafka itself contains, I would say, three pillars. One is a distributed transactional log, the one that we call Kafka. Everyone call Kafka the system that will be performing these like partitions, topics, and stuff like that. Now you learn, or you knew, and I refresh it to you. You have a Kafka Connect that brings data in or takes data out. And now we need to do something in between. Remember the a Unix style of programming. You have your sources, you can pipe it into some processing, and after that you can pipe it back. So if you think about this, the creators of Kafka, they also were very much in kind of like a Linux way. Each individual tool should do one particular thing, but this one particular thing should be like really good. So that's why different components separated, and usually people, if they kind of like operating Kafka, they don't really care about Kafka Streams, for example. Or if you are as a developer, you probably heard about Kafka Streams. It's a Java framework, it's a Java library. It's not framework. We're gonna remove this because I got a note from HR. We're not calling this framework. It's a library. It's a library. So Kafka Streams, it's the solution for this pipe. You know, you have a Kafka Connect. It's your pipes, how you can data in and out. And now you have a processing, like your, you know, AWK, TR, all this kind of like a Unix thing that you can process. Now, and interesting enough, we can actually implement the solution for querying this in a transactional fashion or analytical fashion as well. This is probably one of the things that you cannot beat is that Kafka Streams has a very intimate connection with Kafka. Some of the internal implementation things, for example, the way how the Kafka Streams application scales, really depends on your data or your structure of your data or your particular topic partitioning structure. So ingest directly from Kafka. Kafka Streams doesn't work with any other system except the system that talks Kafka protocol. If you talk in Kafka protocol, it can be Red Panda, it can be Warp Stream, it can be even Pulsar. Kafka Streams will be able to work. But you cannot use Kafka Streams, for example, with Rabbit. You need to bring data to Kafka first. There's a concept of a table because Kafka Streams is one of the examples of the tools, and you will be learning more of the tools in 2025 that will perform stateful stream processing. There's two types. One type is a stateless, obviously, and there's the stateful. Stateless, you're doing simple transformations on the fly. You don't need to remember anything, what happens before you get this message. Transformations, filtering, the changing formats, or maybe like updating data, you know, usually time formats or like a timestamp. All these things are very annoying sometimes when you change the time zones and things like that. So that's one of the examples of stateless stream processing. Now, when you need to perform something that's more complex, for example, you're counting the messages. That's we're talking about something that's called state. We need to remember how many messages we counted before while this new messages arrive. So, and the concept of K-table is, I would say, vaguely inspired by what we call in table in streams. It gives in memory kind of key value store because it will represent Kafka topic, but in this way that it can be queryable. And this is what we like to call stream or table, the stream to table duality. So you have your data, say we're playing chess. When we're playing the chess, you have two types of data. Data that represents state of the game, current state of the different the figures on the board. And also, some of the people like to have log of the steps, how we end up here. So in case of something will disappear, for example, someone will try to move around without putting this in the log, or someone will turn this box around, you will be able to recover this. So we can turn the stream into table that will represent particular state. But also, if we're gonna moving and changing state on the board, what happened? Someone unlock us? Nice. I don't need to be anywhere until tomorrow 7 a.m. So you know it's fine with me. I will be talking to anyone who will be listening. So that's what I'm trying to say. Key to table. Now, when you start moving things around, you generate the changes, and these changes will be captured on the log. So I hope this explanation will give you idea what does it mean, the stream to table, table to stream duality. So in this particular case, we use this abstraction called key table. In topic, in Kafka topic, we have a key and value as a record that comes into topic. That's your stream. But we can materialize it into key table that also would be key value representation, but it will be representing current state. Maybe you can put some algorithm and this key table will contain only latest and greatest value from the topic, or maybe aggregated value. If you're trying to say, have a balance sheet, and after that you have a current you know, you have like a transaction sheet or like the ledger, and you have your particular balance on given moment of time. So that's another example. Yeah, this is kind of like something that I was talking about. This is where the this is where, as a developer, you need to understand a little bit more on implementation details. You cannot just fully abstract out. Which is already, I'm taking you from your favorite, like famous and your super fun thing to use SQL, right? Because like Victor, you were talking about SQL. We have a database, we want to query, but now you're talking about some Java stuff. Sometimes that's what you need. Sometimes it's not. But again, that's one of the examples how this can be used. So in this particular case, knowing a key, we will be able to query this, what we called a state store or key table in your Kafka application or Kafka Streams application, in your Java application. But also, it provides you with, since it's a stateful stream processing, provides you capabilities to do something a little bit more analytical. So in this case, it will have some aggregations. We can do enrichment by joining multiple streams and things like that. But still, one of the limitations in this particular case, you still need to know the key when you need to query the state. If you're trying to, say, query the particular record, so there should be something that will, in order to write the query, you need to kind of understand this structure of this object. It can be Java object, the app row, can be the protobuf, something, but you still need to go and deeply understand what you're taking. So there's no like dynamicity, so you can just like write something like a query. Interactive queries is a pretty cool technology. So what it allows you to do, not only inside your application, you will be able to write APIs called key table, get something by key, but also you will be able to expose this key table, say, wrap it in some sort of like a REST endpoint, and this thing would be exposed. Let me quickly show you how this Kafka Streams application might look like. The typical Kafka Streams application will include something that's called topology. Topology or the different frameworks might have a different notion for this, but it's called directed acyclic graph. It's basically, oriented graph where there's a beginning and the end, like your source and your sink, and after that in between is something like operator. In this particular case, this example of like very interesting task called word count, because word count is essentially hello world on any type of data product. Like you start a new product, you need to figure out how you can write the efficient word count. So after that, you will be able to understand how you can do some other things. So in this particular case, as an input stream that we will be reading, we have a stream of words that happened, and we can perform some transformation. So for example, these flat math values will give you kind of like exploded version. You take a word or like a sentence, and after that you explode this in this stream of words. And each individual step will perform some sort of operation. The way how it's done in the big data world, hello world applications, you have a new event, you emit another event. So in this particular case, in order to calculate the word count, we need to run through the stream and emit how many times we see this message. And after that, we'll have a processor that will perform in this particular case count, but also there is a function that is more broadly available. And at the end, we will get another stream that will land in Kafka, but also we will have a store that will be queryable by key. In this particular case, if I want to know how many times I see a particular word, I will just use my word as a key. So that's how it will work. And in order to expose this as application, what I can do also is expose my key value store from my Kafka Streams into something that would be queryable over the web. So in this particular case, interactive queries give you ability to query the store, but it doesn't give you like RPC protocol. So from one hand, it's kind of good because it doesn't enforce you to what you want to use, REST, gRPC, whatever. But from the another hand, you need to write stuff yourself. Thankfully, there's plenty of framework that allows to do this. In this particular case, it will do this like resting point, hitting word, particular word. We query by word, we get the result. It's cool. It's cool for me because I love Java. I love the writing code. But again, not the cool for people who want to do queries. However, you can do like multiple cool things with this approach. We'll take a look on this one. Now, this is something that we covered that comes out of the box and something that you can use without introducing new technologies. Now, next category, kind of naturally appeared because we have a stream of data that comes from Kafka, Kinesis, Pulsar, from any type of modern streaming solution. Why we cannot use SQL to query this? And this is actually a very good question. Answer of to this question, you can find a book called Streaming SQL, Streaming Databases, right? So we do have one of the co-authors of the book, and I learned some of the things from there. So highly recommend. Now, I'm gonna touch. I'm not gonna. It's not gonna cover everything. It's not comprehensive. Just pick up some of the things that I heard, or I know people who are there, or at least I'm reading something about this. So, materialized data stream, rising wave, KeySQL DB. So this is like the 4 things that I want to focus. Again, like I said, it's going to be very opinionated, and the thoughts are my own. There might be something else. The new things, maybe next time I'll do this presentation, something else will happen. It's a very interesting place to be. It's a very packed. There's a lot of new technology that's coming in every other week. Now, some of you might ask yourself, okay, Victor, but is it the Flink? Is SQL can solve our problems? Because people. How many of you use the Flink SQL? Few people. Flink in general. Keep your hands up if you use Scala with Flink. Jesus Christ, man. Oh, Scala people. Anyway, that's great that every year we have less and less people. We get more Kotlin people, for example. I love Kotlin people more. Now, yes, you can do some stuff with Flink SQL in regards of querying the stream. This is not the talk about the Flink, even though current misconception about Flink SQL, it doesn't make, if you apply the Flink to your Kafka topic, it make you kind of like streaming database and stuff. A little bit more. Because in the case of Flink, SQL is more like a DSL that will be compiled down to actual Java code that will be executed. So technically, it's more like a language that allow you to write Java jobs. What was the name of the framework? Hive, right? So this is Hive was writing the Hadoop jobs using SQL, basically. Now, we're not going to talk about SQL. But I know the person who can give you answer in, say, in 5 minutes what Flink SQL is and what Flink SQL is not. And as always, the 2025, everyone knows how to use a QR code. It's a YouTube channel called Confluent Developer. If you will be there, subscribe to this YouTube channel. I would really appreciate. We're going to start some cool new live stream show later this year. So David Anderson, he's one of the people who spend a lot of time in the Flink community, and he has great ability to explain all these things. So highly recommend his video. This is great, and if you will ever see David Anderson, tell him I sent you. Now, oh yes, of course, yeah, just yeah, and this gives me opportunity to fix my camera. Yeah. All right, nice. So Materialize, it's a product, partially open source. There's a managed service as well. And it feels like, again, it's my personal experience of all this, still feels like replacement of like a data warehouse use cases, analytical use case, supports native ingestion from Kafka. And what I think, what it makes the database, what it makes streaming database is that you have some sort of native support of streaming source. You have obviously some language that resembles SQL, but also storage. Because one of the things that Flink SQL doesn't give you, there's no storage that allows you to, you can query in time when you're running this query because the job will be running. But things like materialize, that allows to create this materialized views that actually would be materialized. When you're creating this, you will be able to go and query this after without reprocessing. And this materialized view will be constantly maintained based on new data and based on the query that you created, the way how you intended materialized view to be. As I said, yes, they persisted and queryable. And the cool thing about this, again, interesting observation that you might not agree or maybe you will disagree, which is same, you will agree or you disagree. The Kafka protocol becomes a basically standard of the streaming system to communicate. Again, there are some implementations like Red Panda, the Pulsar has support of Kafka protocol. WarpStream picked up the Kafka protocol to be the language how a client would be interacting with this. It's not the best, but now it is everyone is using. For databases, like databases in old school style, I think the Postgres protocol and Wire protocol became also one of the standards how the systems, and specifically what the things that the streaming SQL systems adopted, is that ability to give you as a developer your own tool. You're still using same old tools. You can use the Postgres compatible tools to working with the system. You have a new set of capabilities like materialized views came from the streaming source, but also remember Connect, right? So Connect kind of gives you same idea, but in this case, it gives you real Postgres or MySQL or Maria or whatever you're using. In this particular case, it kind of pretends. Obviously, you will not be able to execute like only Postgres query. It's a wired protocol, so your tooling will know how to communicate bytes between the system, but you still need to write some of the materialized specific queries. Actually, it's not only for materialized. Some other systems, they also do support the same thing. We'll talk about this. Now, Delta Stream. Delta Stream is the good example of cloud native streaming solution. So what if, we're going to talk about one of the cool tools called KSQLDB in a few more slides, but I think I probably should have changed the order of those slides. But what if like we can have things like KSQL but in the cloud without limitations in terms of like making sure that this application will run everywhere on it or any hardware. So that's the cloud native SQL, because you don't know how they're implementing this and you don't care because it gives you some cool interface. It feels like the companies embraced cloud, but they still have this kind of like the warm fuzzy feeling when their data is not leaving their data center. So that's why I approach bring your own cluster. It's kind of like becomes one of the cool patterns of what I saw in the last like couple years. So essentially, you still have your data. You have some agents that are running next to your data. And the cloud providers only give you kind of like a nice control plane, like something that you logged in, you see your jobs, but your jobs actually running and managed by this, bring your own cluster type of system, which brings kind of the serverless aspect closer to users. It's like you're not fully reliant. You still need to, maintain your light, water for your data centers and all these kind of things, cooling. But and your data, obviously, you need to maintain. But also, you will still give the cloud native tools and maybe potentially have ways how you can integrate with other cloud native solutions. Native integration with Kafka, Confluent, Kinesis. It also supports streaming views and allows to build kind of like a pipelines approach for, again, the use cases of streaming analytics as well. Again, need to learn bigger story. This is a cool thing that was brainchild of one of the people who were initially built the first version of KSQLDB. We'll talk about KSQLDB in a few seconds. Rising Wave. This is interesting. And they position themselves as a streaming database, but also on their website, if you will go there, you can find the comparison with Flink, which we already established. Kind of like Flink is not actual database, but anyway. So Rising Wave is a pretty cool tool, open source, managed service. You can run this on your infrastructure. Probably getting a lot of. I need to check if it's a Rust or it's a Go. I might be wrong about Rust. Rust. Okay, so the double internet points for using Rust, because if you write something in Rust, you need to sell it. Yeah, we've written this in Rust. But for you as a user, you don't really care. You start the container. You open command line tool, which also I don't have it. Yeah, which also Postgres wired protocol. So you can use PostgreSQL command line tool or any UI tools and start writing these queries. Has a integration with Kafka. Let's take a look quickly on how this stuff looks like from perspective of the streaming SQLs. Now, the way how I know it's kind of like people asking, is it like a real implementation? Some of the ideas very similar. For example, I'll show you. Yeah. So. For example, that's a Rising Wave. And using this, I can say SQL-like, because in SQL, there's no kind of source thing, I guess. I don't remember, maybe there is, but I think it's something that we'll add. But this is a case where we take connection to our Kafka and turn it into something that we called, in this particular case, input stream. So that's something that we will be dealing with. The way how it looks in Flink, same use case. Where's my Flink? README. It will look something. Where's my Kafka? Now in Flink, it's called table. Create the table, input table, with the same message that will connect to Kafka topic. It supports kind of different formats, how we can read the data, so you don't need to, parse it around. And now, for all these words that come into the stream, we need to do something with this. And in a Flink, you will be able to do this word count example, but this we will be able to query this result only when we open or running this like a SQL command, and we need to spit out into somewhere in the console. Where is if we can, where's the select? There should be something like insert into. Essentially, we define an output table. And after that, we're writing data back to Kafka. In Flink, we cannot query this. With Rising Wave, we can. So we do stuff like also create this, what they call a sync. And now we have a materialized view that will perform same thing that Flink performed, different wording. For example, it has a Flink has a different the name for the functions that for the parsing and do kind of like a flat map of the messages. But this materialized word count will be available to query whenever I need. So in this case, if my application already know how to talk to the wire protocol with the Postgres, any JDBC driver, you will be able to connect to this system, and you're getting this result back to your application. That's the whole point. Yeah, so there's two functions. In Flink world, we use something different. We use function split,
that also takes the regex, and also has the explode function that will yeah, so that will generate the result. Now, KSQLDB. I can say that it's the first real streaming database. So, KSQLDB. Anyone used KSQLDB before? All right, few people. For those of you who never use this, it's like it is answer to a question: what if we're gonna use Kafka Streams? All this like a Kafka Streams, intimate knowledge of or intimate connection with Kafka, and spice up with basically we tell people not to write the Java code, but write SQL, and that's the idea. How to take the KSQL Kafka Streams and turn it into something like called streaming database. Now you can ask, but Victor, you said that a streaming database is a combination of integration of streaming source, the streaming SQL, and also storage. Like, what's the storage for KSQLDB? And this is where the intimate connection with Kafka has like a double-edged sword. From one point, Kafka would be storage. Kafka provides fault-tolerant capabilities for Kafka Streams. Kafka Streams uses Kafka to do synchronization or like a stores synchronization between the nodes. Since KSQLDB built on top of Kafka Streams, it also getting this connection to Kafka. So, two types of queries will available. One called pull query, meaning that it's your traditional select start from. That's your pull query. You're pulling data. And push query that allows you to execute this query and wait until changes will emit. So if something happens on the Kafka side of things, new data arrives, or maybe something else, some other transformation happened, you will be able to get the result when you're running this. And this thing it can be propagated up to your application. So you can write the application that will be listening for pull queries and send this back to your users on the WebSocket, like with real-time update. This is pretty powerful, and this is pretty cool. This is a pretty cool piece of functionality that I honestly haven't seen on other systems because they were more focusing on pull query rather than push queries. But some of use cases, some of the applications require this type of capabilities. Yeah, like Kafka Streams, but in SQL. I think, let me see if I think I have example that explains couple things. Cool thing about the KSQLDB is that since it's connected to Kafka, you don't need to write anything. So you have a topic value, and it will take you immediately to query this data. Now, another thing is that KSQL has built-in connector system. So if you need to bring data from somewhere else, you will be able to create the table using the SQL statement in KSQLDB, and it will fire up a connector that will be constantly reading this data, connect this into Kafka cluster, and also you can have a connector to ship the data back to somewhere. It's also pretty cool combine of the things that you can do with your data pipelines. And this is how you would look the table that perform this. This will be compiled down into Kafka Streams topology, into this like directed acyclic graph. And how we can query this data, we will be able to create the stream that will be reading all the data. So in this case, we have a table that was created. Remember table, the table stream duality. We created table. Now we also, for query that we querying this table, we creating a stream. We're turning the stream, we're turning the state of this word count into stream of word count. So we will be able to query the stream or like tap our application to the stream. That's the main difference. Victor, but if it's so cool, why you're not talking about this more? Unfortunately, this intimate connection with Kafka, this intimate connection with Kafka is a huge limitation for KSQL DB, and especially on scalability side of things, because of in order to perform like efficiently large amount of data, you need to make sure your topics are configured correctly. And in some cases, it would be very difficult to do. After that, the compute will be scaled only up to certain limit. So if you experience latency, your horizontal scaling of the system, KSQL system, will not going to help much in this case. Another thing is that for this storage capability, this thing that we saving some intermediate results, KSQL relies on Kafka Streams, and Kafka Streams relies on RocksDB as an implementation of this, like a local store that will be capturing data. And in some cases, it causes some issues. I'm looking forward to there's a company that was founded by former Confluent colleagues. They chose their task to implement cloud native storage for Kafka Streams and prove everyone wrong that Kafka Streams is actually can scale indefinitely in the web scale. I'm looking forward what they're doing. It's incredible, and also they contributing back some of their researches into Kafka Streams community, which is win-win. Now, again, a little bit disclaimer here. I spent quite some time in the world of real-time analytical databases, because we're going to talk about this in a few seconds because of this. And also, you can see there's kind of like a small spoiler. The gentleman is drinking. I tried to make this look like a Pinot type of thing. So I'm going to talk a little bit about the Pinot. We know what this new category of the software. I can say that this is something that emerged for the last at least like 5 years, or like become a very popular. So analytical use case, telling the story based on the knowledge we have from the big data, but also from the fast data, or getting this from ever-changing event streams. So real-time analytical database. Important capabilities for this use case is low latency on the queries, high level of freshness of the data, and also very high concurrency. So this is the systems that were designed to power, kind of last mile, something that power your APIs, that will power your dashboards, something that you will expose to application to your users. Where is like user-facing analytics is another kind of like a type of software that people expose to their users. Like one of the examples that I use a Whoop, which is kind of like a constantly monitoring heart rate. Anyone using Whoop? Anyone heard about Whoop? It's American thingy. It's pretty cool if you on the fitness side of things. What they do, just collecting your heart rate, they can perform cool data analysis on this one and give me dashboards, how I slept, how I performed during the workout, and all those kind of things. So that's a user-facing analytics. Data arrived like immediately. So there's a very low latency between how this data was created. High concurrency, the thousands and millions of users, not the millions, but thousands of users of these devices, and they have the customized use case, but they all still have the same capability, and also very high concurrency. High concurrency, low latency queries, ingest from streaming batch sources. That's for Pinot. So Apache Pinot has same roots that Apache Kafka has. So they both were engineered in LinkedIn. And one of the use cases that they will build Pinot for. I don't know if you're using this. Anyone using LinkedIn in Switzerland? No? A few people. What do you use for kind of like telling that you're sitting on the social network, but you can say it's for work? That's how I say. No? No, and LinkedIn is actually pretty cool. Kind of like what the good social network would look like. Everyone is polite. Everyone is kind of, yay, I changed the job. Congratulations. I lost the job. Sorry to hear that. Everyone is so nice there, right? But another thing that like I like to use this use case, and essentially where this like user-facing analytics thing came to be is that who viewed my profile. Anyone Googled yourself any time of my? I have to do it for work. The who viewed my profile, it's a very cool feature. So essentially everything that happens in LinkedIn happens in Kafka. Every event, you click around, you open your page, you click on this, you write a new post, and every interaction will generate event that will end up on one big Kafka cluster. Based on this data, on this interaction, there was an idea that how we can turn this into something that will engage, will allow people to be spend more time on the platform. So they came up with idea who viewed my profile. So when someone opens your LinkedIn profile, it will generate event, and I can at the same time open my the dashboard analytics, and I see who came in. It can be just why it's analytical, because you'll have a multiple dimensions. You can have a when, so you have a time frame. In terms of like geography, in terms of what's the level, it can be C level, E level, individual contributors like VPs and stuff like that. You can slice and dice all this information. Some people use this for, to get a nice and fuzzy feeling after successful or unsuccessful interview. For example, a friend of mine, he was like, oh yeah, I always check the who viewed my profile, and I feel very good when someone from the company that I interviewed for view my profile after this interview. So it's a real time, meaning that it's a real time in the human mind. It's not a machine time real time, something that in seconds, milliseconds, minutes, because for me, answer, say, who viewed my profile 2 minutes ago or 5 minutes ago, it's okay, I can wait, right? So I'm pretty impatient about this, but I can wait. But like 2 seconds in the machine world would be maybe disaster if you were talking about kind of like things like the self-driving cars and things like that. So for user-facing use cases, analytical use cases, the latency with the 1 second is actually not bad. And the cool thing, you don't need to know anything else. SQL is the standard SQL. And the cool thing is that you don't need to maintain connectors. You just say that this table will be populated from Kafka topic. That's it. Rest of the stuff, Pinot will take care. It will make sure that only fresh data will be here. If there will be disconnection, so it will reconnect and feed this back. And most importantly, the time between ingestion into Kafka and consumption from the Kafka, and the way how this data will be available for liquidity is actually like milliseconds. It's quite fancy. Pinot is not alone here. We do have a Druid, we do have a ClickHouse. They have a similar capabilities, and this market actually becoming like quite saturated. There was a company that also won the world of real-time analytics, Rockset. Yeah. And they were just acquired by OpenAI for gazillions of dollars. I don't know. But the real-time analytics is the thing. Real-time analytics and user-facing analytics is something that you as a developer, if you're developing like user-facing apps, can integrate in your application. And yeah, that's super cool. I talk about the Pinot for quite a while, and there's some bunch of videos that I actually recorded like a full-blown course about the Apache Pinot, like how to get this running and things like that. It is super cool. I'm not working for them anymore, but I still love their solution. Now, I'm trying to be like very quickly here because the most important things I already covered. Now we need to talk about something that I either have zero understanding or some understanding, or I have zero desire to go this way. For me, data warehousing sounds like very boring. Cloud data warehousing sounds kind of like interesting, except here's the interesting thing, that like the icons are all blue. Like, and it's BigQuery, Amazon Redshift, I don't know why logo is blue, Snowflake, and Synapse. Every time when I feel myself kind of like, okay, so what I do with my life, like what I do with my work, I remember that, somewhere there is a meeting with, I don't know, 12, 15 people to discuss the shades of blue that will be used in the logo. And I was like, actually, I'm doing pretty well. I'm doing right. Now, the data warehouses technologies, but put in the cloud. Your data ship there, run different calculations, all the things. You can ingest this from the streaming sources like Kinesis, Kafka, or you can ingest from some batching that you have of files. By the way, like the things that I talk about, Pinot supports both batch and streaming sources. You can have things very similar to what the data warehouse gives you. But the mentality is still in the batch processing. So it moves us to the point where, remember we started with the databases in SQL. It's kind of like a similar approach. You can have a connector for BigQuery that will running this, and you use BigQuery to query your Kafka stream. Now, data lake. So data lake systems that are somewhere we just like go and dump stuff. And in the world of data engineering, it's called ELT. So instead of ETL, when you extract, transfer, load, you just extract, load, and after that, when you need to read the data, you use schema on read, and you can do transformation. So that's where kind of like difference come into play. So everything started as either HDFS. Now everything goes towards to kind of like a S3 compatible object storage, where the data would be stored as a files or Parquet files, different times. It's still kind of like something that I don't want to touch because no one does. People know that they have a data in the data lake, and sometimes we might need this, and we will figure out whenever. So that's why this approach with dumping data and figuring out after, it works in some cases. Usually, I don't know how fresh data in the system. Didn't do any surveys in terms of like the data freshness on data lake side of things, like how and what the requirements people are, or what kind of application they implement on top of data lakes. One of the things that we do at Confluent is that we use approach that was or like formats that was used in the data lake, specifically Iceberg, in order to kind of give a schema and structure to the data in order to perform a query. So we do have in our cloud, maybe it's a solution, maybe it's a future, whenever it will be GA, maybe it's a solution that we will, looking for without talking about other technologies that I already provide to you. So you have a Kafka topic. We have a Kafka topic in our Confluent cloud. Now, with the flip of the switch or something, we can turn this topic into Iceberg table. So we will implement this integration with the schema, and we will get some sort of the way how we can query stream. The problem is, again, it would be latency in terms of like, it's again, our infrastructure provides the ways how we can do this, but it also not instantaneous. Maybe it's a minute. The way how data would be materialized depends on the size. In some use cases, it's fine. In more real-time use cases, like real-time analytics use cases, it's kind of like, okay, it's a very long time. But it's there, and it's something that can be used simply because they support streaming sources as a kind of thing that goes inside in the system. Another problem is that the architecturally, so that's why we do have these different components like a table formats that would be stored inside your storage. Because compute and storage, they very like radically disjoint or distributed. So because it can be in one data center, your compute and your data would be stored in S3 in the cloud. And in this case, research law. Now, that's it. There are no solutions. There are some tools that work for you. Some tools that don't. If you have something that and it works for you, it's perfect. It's perfect. You don't need to do the best thing is best thing you have. I'm a huge fan of Okama's raisin principle. Do not create something that doesn't have to exist. But also sometimes I get very kind of like ADHD little bit and start inventing some of the things. And after that, like, okay, what I'm doing here, I'm solving the problem or I'm inventing new problem with the trying to procrastinate by solving the problem. Sometimes it's something that that you know, and it's not bad if you think that connect and moving data into your table and performance queries works for you. It's perfect. Now, performance is a big aspect. Numbers, this is something that you need to answer. Like what kind of numbers we need to establish baseline. What's the user response time? What's the SLA that we promise our customers? How fast we need to get this data? What's the significance? What's the importance that we need to do this in seconds, not or we need to do it in milliseconds or not seconds? That also can turn into something that would be very, very, monitoring, because the performance usually these days bound to either, cloud costs, or like cloud storages. So that's an important aspect. Some of the solutions would look great on paper, and they will do whatever you want, but in the end, they might be, too expensive to run. And this is sometimes people forgetting about this, but having great community is a great thing to have. So that's why I bring the Scala community. Like once I asked the question, it was 10 years ago. I came from the Groovy world. Groovy was awesome community. Everyone will tell you what to do. It's dynamic question. I came with questions with Scala community, and they told me without PhD, they're not even gonna talk to me. Community is important. Like you're not gonna spend the time with the people you don't like, even though technology is cool. Trust me. There's some better technologies that can be supported or developed and have a better people to work with. Another example that I'm bringing when I'm talking about community, especially on the meetups, is that like if you know programming language, usually you learn this by influenced by someone that you know and trust, but also you can ask this question for this person. Like I learned the Pascal when I was in school because there was a boy who knew Pascal a little bit better than me. And that's the only reason why I learned Pascal. After that, I moved to Visual Basic because my mom bought me a book. Community is important. If you know where to ask the question, and you know that the people who answer this question you trust, so that's important, the consideration choice. Now, I like this picture. That's it's kind of like a map of horrors that you do. So you have your application code, you have a Kafka, and you have a area of exploration or area of opportunities where you can build some cool technology. They go to monsters there. Yeah, you can load some data somewhere in I don't know, like a person over there. So yeah, that's the cool thing about all these things. And I did the small diagramming thing but before this presentation to give you kind of like general direction. I actually invited you to have a conversation. Trust me, not trust me, like you should expect this should be LinkedIn, because I spent a little bit more time talking about LinkedIn. Yes, a conversation on LinkedIn because everyone is nice there. Everyone will be like, yeah, it's great diagram. I have a question about this and stuff like that. So that's great. Maybe I also will post this in Twitter. And there would be the drastically different answer. So with this, my name is Viktor Gamov. We do have a word from our sponsor, but many of you already tried this. My name is Viktor Gamov, and as always, have a wonderful day.